Alright, so talking about fluid technologies which are based on solubility. Fat and dirt are hydrophobic, meaning that they're afraid of water. Hydrophobic materials do not dissolve in water. A detergent is a substance that can remove dirt from fabrics. Most detergents are liquids or powders that are soluble in water, and they contain a cleaning agent called a succinfant. So how does that work? Almost all surfactants are long-chain chemicals that have a polar end, or a water-loving hydrophilic end, and a non-polar end, or a water-hating or hydrophobic end. The non-polar end is attracted to the grease or the oil and the dirt, where the polar end is attracted to the water. So soap encapsulates the fat and the dirt molecules in the water, removing them from the fabric. In this way, the dirt and the water form an emulsion, which can then be drained away. Phosphates were once used as detergents, but the environmental side effects were bad because phosphates encourage plant growth. Phosphates would cause weeds to overgrow in water systems and choke out the sunlight. And this is something that we know is very important for water systems to have lots of sunlight, for them to be able to have a wide range of animals living within them. So if we look here at detergent ingredients, we have a succinfant, which is what cleans the fabric. There's a filler to prevent clumping, a suspension agent, which prevents reattachment, bleach, which removes stains, fragrance to add the scent. There's a builder, which softens water, a corrosion inhibitor to prevent rusting, enzymes to remove protein stains, optical whitener, which adds brightness, and a coloring agent just to give the detergent a nice color. Now if we look at dry cleaning was invented in 1855, wherein a kerosene lamp was spilled on a tablecloth and later cleaned. The tablecloth seemed much more cleaner, so the dry cleaning process was born. Early solvents, such as gasoline, kerosene, and carbon tetrachloride, and trichloroethylene, and had some success in cleaning clothes, but the disadvantages to the safety of those using the solvent and the environment led to the development of a synthetic solvent named, well, we're going to call it PERC. The dry cleaning process is also very efficient. The water and the dryer are all together in the same machine, and almost all of the PERC can be recovered and reused over and over again. Now, if we talk about diving decompression, so if you're going below the surface of the water, it is now possible because of the use of scuba, so self-contained underwater breathing apparatus gear, which is air tanks and regulators, and they were invented to help a diver breathe underwater. So when you go deeper, nitrogen can dissolve into the diver's body cells and tissues in a higher concentration than it normally would. As the diver rises slowly back to the surface, the nitrogen will leave the body gradually. But if the diver ascends too quickly, so goes up in the water too quickly, the nitrogen gas bubbles out of the blood and tissue and collects in different parts of the body, causing extreme pain. The bends, which is this process, it can be treated in a hyperbaric chamber, which forces the nitrogen to redissolve back into the blood and the tissue. This is very, very dangerous as well for scuba divers. If they go up in the water column too quickly, then these bubbles can actually travel to the heart and have a lot more serious complications than just having this bends or this traditional pain. In the next video, we're going to be talking about pumps.